All right, sounds good. Thank you so much, Lori. I'm Jessica Christofferson. I'm a senior stormwater planner with Osborn Consulting. I'm joined by three other colleagues that will introduce themselves as they present along the way. And then we also have Parametrix, Julie and Erin from Altaterra, who are going to be giving presentations after mine. And we're here today to talk about how to effectively meet the NPDES Phase II mapping requirements. So on the agenda for our presentation today, we're going to go over why we're here today. I'm going to provide a high-level overview of the permit mapping requirements and timelines for both Western and Eastern Washington Phase II permits. There's a few different nuances, so we'll cover that. And then our team is going to give an overview of three projects that we have worked on for the city of Everett. We are going to talk about tributary basin mapping. For the city of Anacortes, we're going to talk about outfall and discharge point mapping, as well as tree canopy mapping. And for the city of Issaquah, we're going to talk about tributary basin mapping. To wrap up the presentation, we'll do a project recap summary. We'll talk about lessons learned, both from GIS and data management perspective, and we'll close it out with a short conclusion. So why we're here today. All Phase II permittees have to comply with the new mapping requirements, and there's a lot of different ways to approach this based on your agency and the information you have readily available. So we're here today to talk about all the different ways you could go about approaching meeting these mapping requirements. On my next slide, I will show the number of agencies across the state that are impacted by these requirements. It's quite a few, just to give you a high-level overview. And then based on the project examples that I just described, we'll talk about how each jurisdiction is approaching these mapping requirements differently, as I previously mentioned. Why are these requirements important? It's important to think about how completing these requirements will inform your overall stormwater program. So the way you approach this mapping will be used for other efforts in the future. So thinking about that's important. Understanding how much infrastructure your agency has is also critical too, and understanding the level of effort to get this mapping work completed. And in the end, hopefully you'll have an understanding of how much area is being treated and or controlled in your jurisdiction right now. And then we'll also share the lessons learned from methodologies and approaches we've taken from the three different Phase II permittees. So I know the audience here today is from across the state, so I just wanted to highlight in total how many Phase II permittees there are. There's 85 cities, 5 counties and those counties have different permit coverage areas that have to comply with these mapping requirements. On the east side of the state, there's 19 cities and 6 counties that also have to comply. So in terms of the requirements, I know a lot of you may know the permit requirements, but for those that aren't as familiar, I'm just going to do a high-level review. All the requirements are the same between the two sides of the state, but except for the tributary conveyances and tributary basin mapping. So I'll go over those in review here. So no later than March 31st of 2026, it's required to submit all locations for known MS4 outfalls, and you need to report the size and material of those outfalls where known. No later than December 31st, 2026, agencies are required to map tree canopy to support stormwater management on permittee-owned and operated properties, and we'll talk about what that means a little bit in our presentation, and then Julie's also going to go in depth on how that can be defined, because there's a lot of flexibility in that. And then to develop a methodology to intentionally identify canopy for stormwater management purposes. So here's where the difference lies between Eastern and Western Washington. So no later than December 31st, 2027, in Eastern Washington, you're required to map tributary conveyances to all known outfalls and discharge points within 24-inch nominal diameter or larger, or an equivalent cross-sectional area from non-piped systems. The following features and attributes must be mapped, including your tributary conveyance types. So in my mind, that's like pipes and ditches, material and size where known, the associated drainage areas, and land use. In Eastern Washington, the format for mapping is an electronic format, so it can be GIS, CAD drawings, or other software that's similar to that that has mapping standards and features. So it's a little bit different on the west side of the state. You have until March 31st, 2028 to map and assess acreage of your MS4 tributary basins to outfalls of the 24-inch nominal diameter or larger, like I mentioned before on the east side, or an equivalent cross-sectional area of non-pipe systems that have stormwater treatment, flow control on permittee owned or operated BMPs and facilities. And then the requirement is to submit a PDF or Excel table that breaks down those tributary basins and estimating acreages managed or unmanaged by stormwater treatment and flow control BMPs and facilities that the permittee owns or operates. And then the final requirement is no later than December 31st, 2028, you're required to map overburdened communities, excuse me, in relation to stormwater treatment and flow control BMPs and facilities, outfalls, discharge points, and tree canopy on permittee owned and operated properties. And then finally, you need to update your tree canopy goals and policies to support stormwater management. So with all that outlined, we're going to jump in and provide some examples of what these requirements mean and how they can unfold. So I'm going to pass it over to Courtney, who's going to talk about the use of permit terms in mapping compliance.
Hi, my name is Courtney Dale. I'm a civil engineer at Osborn Consulting, and like Jessica said, I'm going to talk about some permit terms and how that can impact your mapping compliance, and then also going to be talking about a project that we have done for the city of Everett, where we kind of put some of this into use. So I'm sure we're all familiar with what an MS4 is. It's your municipal separate stormwater system, which is your conveyance system, including drainage systems, streets, catch basins, curbs, gutters, man-made channels, storm drains, all of that. The three things that you have to map and be aware of when you're doing this mapping are called connections, discharge points, and outfalls. So a connection is a connection point between your city's MS4 and either another MS4. So this would be at the city limits from the city into the county, or also from a private or system into the city system. So this is where your private storm drainage system for a housing development or something like that connects into your MS4. So that's a connection. And then discharge points are where water goes from your MS4 into infiltration facilities. One thing we've identified and noticed is that this is not per connection to the infiltration facility. So if you have a bioretention cell that has 3 pipes coming in and discharging water to it, you would have a single discharge point for that bioretention facility. And then finally, you have your outfalls, which is kind of what most of us probably think of when we think about mapping outfalls. That's where you go from your MS4 to your surface receiving water. Next slide. So I'm going to talk about a project we did for the city of Everett. This project is actually not a mapping specific project. This is we're working to site regional stormwater facilities. However, as part of this, the city of Everett decided to also incorporate updating their MS4 mapping. Previously, their previous studies they had done had identified 3 watersheds within the city and then 23 drainage basins, and they also have a pretty large CSO. This project was grant funded through an ecology grant. However, the city decided to kind of piggyback and use some of their own funds to add some of the mapping work to this because it was going to be really helpful for the actual project and was something that they needed to do anyways. So instead of doing it twice, they just wrapped that into our contract. So for this project, what we ended up doing was we used a combination of existing mapping, the 23 drainage basins, the topography and contour data, and as well as the conveyance system mapping to delineate the individual catchments. So this is a pretty manual process. It's a pretty involved process. Can talk about how many outfalls and connections we ended up with a little bit later. Next slide. So kind of our process for this was first we took the city's known outfalls. They had a pretty solid map of places where they thought they had outfalls or connections or discharge points. We did a desktop review in GIS, and then we sent out a field crew worker to go identify and confirm any additional outfalls we found during that desktop review. So the main thing that came out of this project is that the mapping quickly expanded the scope of the project. Like I mentioned, an outfall is defined as anywhere where water enters a surface receiving water. The city of Everett has a number of locations in which a stream is partially piped through large portions of the city. So you have places where you have piped streams, huge number of private connections that were not mapped. And in some of these locations with the piped streams, each individual catch basin was an outfall. So in the image below, you can see this is Evergreen Way, which is a pretty major thoroughfare through the city of Everett. There was over 30 outfalls along this street because there is a stream that is piped through underneath Evergreen Way. So this very quickly expanded our scope and the number of catchments that we identified. Next slide. So for these projects that we're going to talk about today, we kind of defined a level of effort comparatively. This is our highest level of effort of the three projects that we are going to talk about. The city is very large, pretty large compared to the other cities we're going to be talking about. It's highly developed. They have a large storm drainage system. They also have a significant number of water bodies within the city. There's 23 receiving waters within the city, and then there's additionally smaller lakes, ponds, wetlands throughout. So as you can see below, we started with 380 outfalls, and we thought the city had a pretty good understanding of their system. We ended up delineating 546 catchments. We did simplify and kind of combine a lot of those single storm drain catchments into larger catchments. For the purposes of this project, the city will have to go back through and break it down a little bit more for the permit mapping compliance, but this is a really good start because they now have over 1,000 outfalls, discharge points, and connections mapped throughout the city. So they started with 380 and ended up with over 1,000. So kind of a good example of how quickly you end up seeing how much more you have than you think you do. And I'm going to hand it over to Katrina to talk about a couple of different projects.
Hi, my name is Katrina Tang. I'm a project engineer at Osborn Consulting, and I work on a lot of planning and asset preservation projects. So today I'm going to be talking about our project with the city of Anacortes, where the overall goal was to help the city meet the NPDES GIS mapping requirements. The major categories of the tasks for the project was discharge point and outfall mapping, tree canopy for stormwater management, and proximal overburden communities mapping to the discharge points and outfalls, and tree canopy. For our discharge points and outfalls, we helped them update their outfall layer. So we filled in some data gaps for missing attributes in their layer, such as diameter, material, and we also went out into the field and investigated suspected outfall locations mapped by other entities. We also helped the city with their discharge point mapping to infiltrative BMPs, as shown in the figure on the right, and we will be mapping their tributary conveyance and basins to the discharge points and outfalls. For tree canopy for stormwater management, it doesn't have the most intuitive connection to stormwater, but the purpose of mapping tree canopy is that tree canopy can help reduce stormwater volumes and velocity by slowing and storing rainfall, which can delay peak stormwater runoff rates. So the process that we used to approach this was we looked at the infrared imagery. So we sectioned out vegetation from other land cover. So in the figure on the right, the green is the vegetation and the yellow is other land cover. Then we looked at the LiDAR to help calculate the tree heights. So we looked at the DTM, which is the digital terrain model, which was the elevation of the tops of the tree, and we looked at the DSM, which is the digital surface model, which was the ground elevation. So subtracting them, we were able to calculate the heights of the tree. So combining the vegetation area and the heights, we were able to get the tree canopy. There are other options for tree canopy depending on your accuracy and requirement needs that can be found at this link right here. Ecology's requirements in the NPDES permit is that permittees shall develop and follow a methodology to intentionally identify canopy for stormwater management purposes. The wording here is a little vague, so we definitely worked with the city of Anacortes to develop what they wanted to be included. For example, what density of tree clusters to include for their definition, but also what they wanted to exclude, such as trees that could prevent maintenance for their BMPs. For this project, we were definitely able to look at the overall process that we wanted and collaborate to avoid reinventing the wheel to cut down on the level of effort. So for example, of using what was already created, we used the delineations for the stormwater master plan as shown on the right, and that is a good starting point for the tributary mapping for outfalls and discharge points. So we created this in a previous effort for citywide hydrologic and hydraulic modeling, and we're just repurposing that and using the delineations from there. We also looked at the Friends of Skagit County Beaches outfalls to make sure that the city had the most updated outfalls mapped if any of them were missing. We collaborated with a researcher from Washington State University who's doing a tree canopy progression study to see what data they were using as well as what processes they were using to see if we could use anything similar. And we will be using the overburdened community data from the Department of Health, specifically ratings that are 8 or higher. For our outfall mapping site visit, we decided while we were out there that we could gather extra data while we were out there. That's not necessarily required by the permit, but we noticed some data gaps when we were doing the citywide modeling, such as outfall elevation, that could just help the city in the future. And for the overall level of effort compared to the projects that we're talking about, we said that this was a medium to high level of effort because even though there are multiple deliverables and parts to this project, the city has less infrastructure compared to Everett, and we're also able to cut down on the level of effort by using what was already created. And now I'll talk about our project with the city of Issaquah. So the overall goal of the project was to calculate pervious and impervious area flowing to city-owned BMPs. And although it's not directly related to NPDES permit requirements, in the same vein of using what was already created, the city could use this as a good starting point for tributary conveyance and basin mapping for discharge points. Our process for doing the delineations was one, examining the data, so looking at the image to the right, like for example, those pipes aren't flowing into each other, and also using contours to create these delineations. And once the delineations were done, we were able to do some post-processing and calculate the overlap between city right-of-way and private right-of-way, as well as calculating the overlap between pervious and impervious surfaces. Compared to the other two projects that we talked about today, we said that this was a lower level of effort because of the smaller and more specific scope. And now I'll pass it back to Courtney to do a recap of all the projects we talked about.
Yep, so just going to kind of recap and summarize some of the lessons learned and the things we really wanted to emphasize with the different projects. With Everett, again, this is our highest level of effort project, biggest city that we worked with within the MS4, the large number of mapped outfalls. Big lessons learned were making sure you understand and are very familiar with the permit terms and how the mapping interacts with those, as well as, so for that was what we learned with that, and also thinking about what kind of other projects you might be able to use to leverage to do this work so that it can kind of be mutually beneficial from a different project. Anacortes, the big thing was the collaboration and using existing data sources. This is our medium effort project, a smaller MS4 and a smaller number of discharge points and outfalls. But we did a little bit more work and touched on more of the permit requirements on that one. And then Issaquah, the actual project scope was just limited to the discharge points because we were looking at the infiltration facilities. But again, it's just looking at the data verification and utilizing the existing data or the existing information available. I'm going to hand it off to Heather to talk about some of the GIS and data management information we learned.
Hi, I'm Heather Spates. I'm the GIS Analyst here at Osborn, and I do a lot of planning and land management and other types of projects. I actually worked on all three of these projects. It was a big data gathering effort, and including the tree canopy. And what we found out is it's really important to have good, clean data. You need to double check to make sure if your outfalls or your pipes are having all the requirement fields and all the right documentation for that. Understand what you need, discharge points, stormwater infrastructure locations, things like that. If you do have gaps in your data, you can also use your mobile technology solutions to have people go out in the field or remotely sense information to fill in those data gaps. And it's really important to do this cleaning data before you start your project. It helps reduce the amount of time and rework that you may have to do. So I'm going to go ahead and pass it back to Jessica.
Thanks, Heather. So in conclusion, we suggest you start early, understand the timeline for permit compliance, allow enough time to dig in and do the mapping efforts correctly. It may take more time than you think. Like in the case of Everett, there's just so much infrastructure, and the project really grew as we dug into it. Consider leveraging on-calls or rosters to get consultant help if you so need it. Just make sure you allow enough lead time for that, or set up, make sure your staff is available, that they can spend the time needed to implement these requirements. Think about your scaled methodology and approach. So as you saw in our presentation, the size and scale of your agency and the amount of infrastructure you have really impacts how long it will take to meet all these requirements. Ensure the methodology is very clear and you have good documentation. So think about the future if you need to go back and update this and future permit requirements. Leave a good paper trail behind for the next person that may have to repeat the work that or update the work you've done. And then also think about the projects you have upcoming or ongoing, such as stormwater master planning work, excuse me, to leverage that work. We mentioned H&H modeling and regional stormwater facility planning. So this mapping can be used for other master planning efforts to benefit your agency. So think about that. And then also consider, if you want to go after grant funding, what those grants may be and what their where your timing is on the grant cycle in order to leverage funding from the state to implement these requirements. So that concludes our presentation. We'd like to thank Erin with the City of Anacortes, Alan, City of Issaquah, and Eric for the City of Everett. Feel free to reach out to them if you have any specific questions on their projects, or feel free to reach out to one of our team members as well, and we'd be happy to answer your questions. That's everything from us. I think we're gonna leave verbal questions till the end, so I'll pass it over to Julie.
Excellent. Thank you, everyone from Osborn. All right, I will get cracking here. Let me know when you all can see PowerPoint presentation.
We can see it.
Excellent. Okay, so hi, I'm Julie Brandt. I'm a senior surface water engineer with Parametrix. And today I'm going to be talking about these three elements of the NPDES municipal stormwater permit requirements. I'm going to talk about hydrocanopy mapping, that's what we call the trees, stormwater management coverage mapping, and overburdened communities. And all these citations are from the Western Washington Phase II permit, but some of these requirements do apply to Eastern Washington in Phase I. So first I want to talk about hydrocanopy, and you may have heard me use the term stormwater trees in the past, but we found that that was causing confusion. So there were folks from, when we've been working with surface water management departments, we've had folks from other departments immediately try to translate the phrase stormwater trees into the singular. And they got really stuck trying to identify what an individual stormwater tree might be. And hopefully it'll become evident as I go through these slides, but the idea of focusing on a singular tree is in exact opposition to the recommendations we're trying to make. So we wound up working with City of Bothell to develop the term hydrocanopy and have been using it for other jurisdictions. So we're here to talk about the mapping, but if you look at the other tree related requirements in the permit, they provide context. The mapping requirement asks you to intentionally identify canopy for stormwater management purposes. And in mapping, it says for permittee owned or operated lands. If you look at the goals and policies, which I'm going to touch on briefly later, that goes on to highlight that talk about tree canopy supporting water quality improvements in the receiving waters and mature canopy. And that's important for some of the background that I'm going to walk you through in a minute. And Bill Leaf, who I think is on today, also pointed out to me recently that the goals and policies requirement is not limited to permittee owned or operated properties. So that's something to keep in mind. So those last words that I mentioned about water quality improvements in the receiving water are really important because they reference ecology's basis for their requirement that I'm going to talk about. So before getting into that, as through the steps, we do recommend that you start by mapping all of your trees. And Osborn talked about this a little bit, and how you do that matters. So Washington Department of Natural Resources has some work going on right now that they've been encouraging the use of the 2016 LIDAR data for some Growth Management Act work. And we found that there have been internal pushes from especially planning departments at other jurisdictions that say, like, why wouldn't you use this same information for mapping your stormwater NPDES trees? However, when mapping the canopy for the permit, for the stormwater permit, we highly recommend that you use the latest LIDAR from Washington State, which is the 2021-2022 data set. And it's got several important layers that are all shown here that when combined, they give you a more accurate result in confirming tree presence. Because they can discern between shadows and building and vegetation height in our, and Osborn touched on that as well, that in our analysis, we pull anything that's 10 feet or above, we count that as a tree. And then other elements that later LIDAR set helps discern. So this example, if you look at the series of photos that I have over on the right-hand side of the slide, you can see how this is the exact same site. And the 2016 canopy layer, the one that DNR has been using, this is an example of an area where it overestimates the tree canopy, and it called all of those areas that were grassy in the middle, they called that trees. So if you use these two data sets for comparison as well, be careful because it can look like tree loss has happened when in fact it hasn't. So here's an example of mapping the physical coverage of the trees across a jurisdiction, in this case, City of Bothell. And you can see that the mapping really does help differentiate between the individual street trees and overall forested areas. And here you can see how we categorized it by height. So the more mature, taller trees are red. So that helps you with one of the, later on, they talk about that in the permit. And here you can, and this is what it looks like when you don't count anything under 10 feet as a tree. So flipping back and forth, there's all your trees, but then you can see you're more mature. So now I'm going to get in a little bit to how we recommend that you think about hydrocanopy. So you've got all of your trees mapped. And as I said, we don't recommend that you include all of them in this permit requirement. One thing to consider is that canopy that you declare applicable to this permit requirement and report to ecology has the potential to become a legal part of your permit compliance that you may have to protect in ways that you haven't anticipated. Ecology has been really helpful and really given really good feedback in several of these sessions saying, hey, we don't yet know how we're asking you to use this data. We just want to collect it. Let's figure out what's out there. But we make this recommendation of caution in the same spirit of when wetland, if you think about how wetland protections came to pass over the years, that these, what I'm going to get into is the forests and the tree clusters. They're important. I believe they're important natural resources. Just be aware that they may fall under protection once you report them for the permit. So for help in identifying which trees to report, the permit fact sheet explains that a lot of the basis for these new tree-related requirements comes from a 2018 SAMS study, where they found that in watersheds where the stream health measured in BIBI, in the streams, the threshold they used was where the BIBI passed from poor to fair, where it was getting a little bit better in those streams. And they looked across all the different watersheds and they found that forest coverage, like the percent forest coverage, was the biggest factor determined whether or not the streams were healthy or not. And the ones that passed the threshold into fair, somewhat healthy, had a minimum of 67% forest cover. Most of you with urban jurisdictions aren't going to come close to 67% forest cover. But do bear in mind that they were talking about forests. They weren't talking about street trees. And urban areas in that SAM study where they were looking at the health of the receiving water, all the street trees were lumped into the urban areas, and those were not found to contribute to the health. So even just thinking beyond that, going back to biology, think about what makes a forest hydrology unique, that you've got full canopy coverage during rain, your mid-story intersection, your canopy closure, and then your understory duff complexity and your root networks and your soil layering. So even a deciduous forest that has no leaves in the wintertime, it's going to have those last three elements. And then to the folks, I always want to address the challenge. You get folks that say, well, I stay dry if I stand under a street tree during a rainstorm. And that's, I always tell folks, I'm from Chicago. Like, yes, that's true in Chicago in a summer thunderstorm. However, here in the Pacific Northwest, if you're standing under a deciduous street tree during, one of our winter design storms, 20 minutes into that design storm, you and that bald street tree are going to be soaking wet. So I want to be really clear that street trees are incredibly valuable for tons of different reasons, but they're just not what we're recommending today regarding the permit requirements. So to identify what is relevant, and I always talk about for stormwater management and water quality improvements in the receiving waters, because that's, when you look deeper into the permit, that's what it says in some of the later requirements and the fact sheet. We recommend first categorize all your trees into like 4 different chunks. So you have your street trees, we call those hardscape trees. And then think about individual trees with soil that are surrounded by pervious surface, like you might have in a park. And then larger stands of contiguous trees. And for our purposes, for the jurisdictions that we're working with, we've started with 10,000 square feet up to about 3/4 of an acre, we call those tree clusters. And you can adjust those parameters according to what makes sense for your jurisdiction. And then anything larger is a forest. And when we're mapping these, another important consideration is that if there's any one of those categories that's in a riparian buffer, we promote it to the next category. So if we have like a single tree with soil, we will bump that up and include that in the hydro canopy if it's next to a stream. So it's the tree clusters and the forests that we recommend, that I've said before, but I want to make sure to say that out loud, that that's what we recommend, that you consider hydro canopy, and then that you report that to ecology for your permit requirement. You can always add more trees if you want, but maybe consider adding those later. And another thing too is that all these categories can be used to help define long-range plans and policies, and we've got a little way of scoring them for planning purposes that I'll touch on briefly. So before that, here's another citywide example of all the full canopy mapping. This one's from Des Moines. And then this is what it looks like when it's separated out into categories. Those hardscape is yellow, the tree with soil is brown, and it's the light green and the dark green that we recommend as hydro canopy that you include in your permit reporting. And as an aside, here's some important considerations that I just want to add. We developed this recommendation about the hydro canopy and focusing on the forest and these tree clusters based on its own hydrologic merits. But as we've been leaning into this with different jurisdictions, so far we haven't found any local codes that protect forest as a natural resource independent of any other category. So for example, like if you have forest, we tend to see that if there are forested areas that are not part of a critical area, like if you squint, there's the stream buffer running through the center of this map. The forests outside of those areas are typically not protected resources. So that's something to consider for your jurisdiction. This is the scoring methodology that I mentioned. Categories are assigned a subscore based on their relative impact to the receiving water health. We use 0 to 100 as a default. You can adjust that for your jurisdiction, whatever makes sense. Then through different calculations, based on what types of tree categories are on how much land divided by the total land, you can get overall scores that can be used for long-range planning and informing development of maybe your tree goals and policies for your jurisdiction. Here's a couple examples of jurisdictions we've run this for. So now, finally, for the tree canopy, briefly touching on the future goals and policies, we've been finding that these choices are wide-ranging and they're of which goals and policies jurisdictions want to adopt. And very specific to each permittee's needs and opportunities. A lot matters on what kind of relationship you have with the public and different departments. We found that most communities agree on item 1, to protect existing hydro canopy on public lands. And several others are even, really leaning towards agreement on numbers 2 and 3 about maybe let's look at lands where you can start planting trees, especially riparian, and then look at upland possibilities. So going back, remember that the goals and policies requirement, as Bill pointed out, is not limited to permittee-owned lands. So items 4 and 5, which relate to private lands, are under consideration by several jurisdictions, and we offer them here for your reference. And one thing of note for almost every community that we've worked on in thinking about those forests on private lands is that we have found that the largest % of forested areas are all on private lands. So most jurisdictions don't own most of their forests. So These are considerations as you're getting beyond the mapping requirement for your hydro canopy. Next up, I want to talk about the stormwater management coverage mapping that we've worked with a number of jurisdictions on this approach. Here's the legal words from the permit. This is all due in 2028. You want to map and assess acres. I'm going to be talking about not your outfall mapping, but the requirement that says you need to map, figure out how much of your jurisdiction, how many acres are covered by flow control and water quality treatment facilities. And this does apply to facilities owned or operated by the permittee. And I like to give Myron Borchards up at Mukilteo credit for this, because he pointed out to me a couple years ago, like in Mukilteo, they had to look at all of their stormwater facilities in order to separate out what was public versus private. And we're actually working, I think Brian Monin, you're here today. We're helping City of Camas kind of discern some private and public facilities, and where public right-of-way might be draining into private facilities and so on. So just be emotionally prepared to maybe look at more facilities than you may originally think. So I'm going to present a high-level approach to this mapping requirement that Ecology actually had a chance to review before they wound up putting it in the permit. We use this, Parametrix used this approach with a number of jurisdictions we worked with on the first round of the SMAP requirements. So you want to start with whatever existing stormwater facility mapping you have. Again, going back to Camas, that's here's an example from them, and we've got all these stormwater facilities mapped, and they're showed by stars here. But the trick is that you need the tributary areas that discharge to these facilities, and if you don't have those if you have them delineated from the as-built, fantastic, use that. But otherwise, it can be a lot of work to delineate them. And I want to show you this shortcut that we used with the SMAPs that we submitted before this permit requirement even came to light. So the first key element that makes this approach simpler is not delineating anything new. Start with the subdivision boundaries from your tax assessor's office. And this provides a relatively quick, but still roughly accurate delineation of the areas that are served by these facilities. And you might have some anomalies to work through. I've got little examples in yellow here, but you're much farther along than if you were trying to do manual delineations. And in addition, by looking at your parcels, you're also going to have some answers for areas that you may not even have the location of a facility identified. For the next part of this process, you need dates. In instances where you already have them from your as-builts, the installation dates of the facility is fantastic. But where you don't, supplement those with the parcel permit dates. And then you put those dates, those installation dates, to use in the second part of this process. Categorize your coverage based on your jurisdiction's milestone, like historical milestone dates for water quality and flow control requirements. And you might have different dates for water quality versus flow control. But for water quality, it's go back in time and find the date where you first required basic settling. And then for flow control, when did you first require peak flow reduction, just on flow frequencies, just using the existing condition as your target. That milestone date and everything after that, we call that vintage. And then anything before that, just say you didn't have, there was no coverage. The next milestone year is for water quality, when you started requiring enhanced treatment, metals removals, more treatment trains. And then for flow control, it's that moment when we all started using forested conditions as our target when we adopted the ecology manual, when it said forested conditions for target and stream duration standards rather than just flow frequencies. Everything after that date, call it current. So now, and on this slide, vintage is shown in pink and the darker magenta is the current. So in the next step, if you have land cover, use it. It's a really good qualitative indicator of your base level pollutant load and also your tree canopy management. So everywhere that you have treatment, you might want to deprioritize those areas for this, that, you know, so this you have your mapping. You can use this for your permit requirement. Moving on, I mean, part of the reason we came up with this process was for the SMAP for long range planning. So now you can approach those untreated areas as priorities for future planning. There's a number of jurisdictions like to consider buildable lands in this step. So those are shown in brown, with the idea that these areas might be brought up to code by third-party developers. So maybe your jurisdiction doesn't want to prioritize those right away, and that it's really the areas that are left unshaded after you've considered buildable lands. And then those are the ones that you want to target for retrofit first. And you'll also see what I've shown in the, and I'm sorry, let me clarify, the ones that are the most highly developed. So you can see here, you've got all these areas with roads, and those are the ones you want to target. The areas shown on the south end of the drawing, you know, flipping back and forth, like, yes, those are slated as buildable lands, but then those you might also want to consider for tree canopy. You know, do you want to make any adjustments to that zoning to protect any of those forested areas? So that's the process. It's meant to be a quick and cost-effective way to get a relatively meaningful idea of your stormwater management across your jurisdiction. You can use it toward the permit requirement now, and then you can always collect more detailed data as you go. But then this gives you a way to take care of that requirement for now. So finally, I want to talk quickly about overburdened community mapping in a project that we did with City of Renton. The permit borrows its definition of overburdened communities from the Washington State Department of Health. So we've got a summary from Department of Health here on this figure. The identification starts with vulnerable communities who have had an environmental threat inflicted upon them. Those two metrics together create an overburdened community. And specifically to the Washington Department of Health Environmental Health Disparities Mapping Project, any area that scores as a 9 or a 10 in their process is considered an overburdened community. You can adjust those metrics for your jurisdiction. So in our project with City of Renton, they were interested in using, you know, Department of Health metrics as a guideline, but going a little bit beyond to see if it would provide more custom answers for Renton. So in the figure here, we used all of the metrics from Department of Health, and they're shown by stars in this figure. And then we added a few more metrics to help refine the identification process, and those are with the circle bullets. And in addition to the Department of Health metrics, for the Department of Health metrics shown with stars, we also pulled the most recently available data, and some of that was a little bit newer than what's shown on DOH's health disparities map. So in the end, the plan was always to then, however these results came out, compare them against DOH mapping for Renton to, you know, as a check to make sure at least Renton knew they were on the right track. And if there were differences, make sure those differences made sense. So we generated subscores for each of the categories. Please note that on each of these maps, a darker color means higher need, except for the trees, because our brains didn't work like that. So on the tree map in the green space, anywhere it's more green, that means it has green space. And anywhere it's less green, that means it needs green space. So we combined all of those and we got a composite overburden community score for Renton. And so the city has this data now, and they plan to reference it, in helping them with all of these different permit requirements that are listed here. These all require consideration of overburden communities. And regarding the check against the Washington DOH map, I'm going to flip back and forth a little bit here. It's not the same, but it is very similar. And so the DOH's Environmental Health Disparities Mapping Project is a really amazing, helpful tool, but it is a little bit different. As I mentioned before, it includes some data sets. We were able to add more for Renton. And in addition to getting the more recent data, the DOH information is reported by census tract. And we were able to go a little bit more detailed into census block groups from Renton. So that's just an example of some additional mapping you can do there. Thank you very much, everyone, for your time and attention. And please do put questions in the chat if you have any. And I'm going to turn this over to my esteemed colleagues at Altaterra.
Okay, thank you, Julie. I will go ahead and let me see, start this presentation. Oops, let me see. Share my screen. Okay, can everybody see that okay? Is that the right?
Yeah, that looks good.
Yes, that looks good.
Okay, great. Okay, my name's Erin Nelson with Altaterra Consulting, and I'm the owner, operator, whatever, principal surface water engineer. And I'm going to be presenting with Heather Haskell, who did the GIS analysis for this work from EMA. And we collaborated with Myrene Borchertz from City of Mukilteo. And today we're talking about a specific part of meeting the permit mapping requirements, which was just the tributary analysis. We didn't do any tree canopy mapping or anything. And Julie covered that wonderfully. So that is awesome. I always learn a lot from her. So happy Stormwater Week, everyone. And thanks for inviting us, Lori. Okay. So just to start off, Mukilteo had some specific goals with this analysis. I mean, first of all, it was to meet the NPDES Phase II permit condition, S5C4B1. And the equivalent Eastern Washington NPDES permit condition is shown below. And it's just a little bit different. It was under IDDE instead of the mapping requirements. Additionally, they wanted to use this analysis to prioritize city retrofit projects and also to facilitate private facility inspection and maintenance, to look at where there were private facilities that might need a little more help, to target helping those that weren't under the permit inspection schedule that were before 2007, to look at those as well. So just to refresh, I know Osborn already went through this, but what the permit condition is to map the all known MS4 outfalls, including size of materials, and then of city-owned outfalls, and then to map the acreage of those MS4 tributary basins to outfalls with a 24-inch nominal diameter or larger. So Mukilteo's approach was to meet the permit condition, which is shown on the left-hand side of the slide, and then to do a little bit extra, and that was to map all of the outfalls. So both city-owned and operated and private ones, and to also just map all of the acreage to those outfalls. and report on what the managed and unmanaged BMPs were, including ownership and responsibility to the private facilities. So I know that Dan mentioned something, I think it's Dan O'Brien, I think that was his name, in the chat, mentioned something about the private facilities, like city-owned water going to private facilities and then going to a city-owned outfall. And I know Heather can talk a bit about this, but there were definitely some cases in Mukilteo where that sort of thing is happening, and it's a little bit confusing. So by mapping all of the outfalls and all of the facilities, that was really helpful. And Julie mentioned that too, talking to Myrene about that. So this was entirely done in GIS using the city's existing data set, which Heather can talk to, that it was a pretty good data set already. We used their stormwater BMP data set, ages and types, city-owned and private, and then we categorized them into different groups. We looked at areas we considered something fully treated if it was constructed. We used the date of 2001 or later, and it had water quality and flow control. We considered the area partially treated if it was constructed before 2001 and was just one or the other, water quality or flow control. If it had no water quality, no flow control, it wasn't treated. That's an obvious one. And then if there was no treatment, and we called it exempt if it was an area that didn't need treatment, such as a critical area, a forested area, that we just eliminated that. We used the conveyance network and outfalls, all sizes, like I mentioned earlier, the hydrography of streams in Puget Sound, where was the water going to, where was it outfalling to? So we kind of divvied things up by basins. We looked at impervious surfaces. The land cover was evaluated, and we'll talk a bit about that. And then, of course, the critical areas where we eliminated those. So I'm going to turn it over to Heather now, and she can introduce herself as well before going into the GIS analysis.
All right, thanks, Erin. So I'm Heather Haskell from a consulting company called EMA. Our headquarters are St. Paul, Minnesota. I actually live in West Michigan, but Erin and I have worked together on a number of projects in the Western Washington area. So I been in the business about 20 years. My background is GIS and water and wastewater asset management. And I love, Erin, doing your technical analysis. It makes me happy. So with this project, so we went, I would say it's more the high level of effort side, but lucky for us, Mukilteo is a physically smaller community, 1.4 square miles, about 900 acres, I think. But they have really, really good GIS data. I jotted down a couple stats here, but in all, they had like 683 outfall and discharge points, mapped with size, with ownership. So we were able to start there. They have all their BMPs and their stormwater facilities mapped. So again, we know what their detention facility is, public, private, what type, and with our criteria, you know, does it provide full treatment and partial treatment? On top of that, you know, they have their full conveyance system in there. You know, we did find a couple issues here and there, pipes slipped the wrong way, things disconnected. But we were able to basically interrogate the entire network, outfall, all the way up, and then all the way back down to Puget Sound to get a really, really good idea of how their conveyance system works. Erin, could you jump? Yep, thank you. So, so again, with this good GIS data, with all the bits and bobs and things we needed, we interrogated the system and analyzed essentially outfall by outfall, and we did upstream traces so that we could get a visual on what pieces of conveyance systems drain into a particular outfall or discharge point. So The way we built these trace models, we did end up doing this as a manual effort. So we made fewer assumptions, but there was definitely more manual work. But we could, if this was a larger network, we could have automated this and had the system generate some drainage areas or catchments for us. But this screenshot just shows we had grabbed an outfall. I think it's outfall 93, but you can show through our upstream trace what stormwater facilities it hits, and then what BMPs are also attached, like pollution control devices or filters. And we do also make note of ponds. We have our pond IDs and a tracer ponds. Can you jump over to the next slide? Thanks. So to create the catchments, like I said, it was definitely a manual effort. We had looked at boundaries several different ways. Like Julie from Parametrix did, we did consider parcels and subdivision boundaries as one boundary, but we also looked quite a bit at contour lines and just some other natural divisions to show what would be a catchment or drainage area for each outfall. But on top of that, we did set up our data model to be able to log acres that drain through a particular outfall, but we actually split that a little bit more so that within each outfall, if there were multiple stormwater facilities that also offered treatment, whether they were public or private, or fully treated, partly treated, we also included in our data model a way to show how much of an area each stormwater facility treats, and then we can combine that and say how much of this stormwater flowing through a particular outfall is treated. So we're able to slice and dice the data in several different ways by using these little trace networks. And then you can kind of see on the bottom, this outfall, 582, we can see it's owned by Mukilteo. We can tell the acreage it drains, the receiving water. And then with the detention facilities, again, we have numbers. So yes, treated, but they were built in 1985. So by that definition, it means we are partly treated. So next slide, thank you. So our coloring, our symbology convention was close to Julie's, but again, fully treated, we went with a darker color, partially treated, lighter color. And again, we have the data in the back end if it's public or private, but no treatment. And then if there's no treatment and if it was exempt. So catchment by catchment, boundary by boundary, it was really outfall based on this screenshot. Can you go one more slide? Thank you. And then through this project, we worked with a company called Issaquah, and they actually did an AI analysis of all of our land cover. And I have to say, I was a little hesitant at first. I don't fully trust AI, but the output they gave us was phenomenal for determining our higher water quality impact versus lower water quality impact areas. So again, you can very clearly see streets, pavement, houses, decks, things that could potentially carry a higher pollutant load than our grassy or forested areas. So we have our catchment areas and we have our land cover overlay now.
And to be clear, the forest is just trees. You won't call the forest through the trees, or since Julie just talked about forest versus trees. So.
So we combine those data sets then. So for each of those catchment areas, we have the outfall ID, again, the outfall size, but marrying the land cover data with the catchment areas, We can also tell catchment by catchment what percentage or areas covered by roadway, buildings, pavement, grass. There were a good 25 different land cover types. And we included, I mean, all of them in the analysis. This screenshot just shows a couple of the more impactful ones. But we were able to look at each catchment area and say, okay, which ones are the most covered by roadway? Which ones are the most covered by buildings with the least amount of treatment? So by marrying these two data sets up, we were able to get another idea of places that need some retrofitting or maybe stormwater treatment added that didn't have it before at all. Next,
before we move on, Heather, can you talk about some of the lessons learned and some of the things that you needed to do with the data, like the dummy outfalls?
Yeah, so there were several places in the system where we were doing those upstream traces to get the idea of a conveyance system. And there were places in the network that just would not trace. Our upstream traces stopped and our pipes would not highlight. So we ended up having to add about 150 more discharge points throughout the system just so that we could do those upstream traces. We made sure to mark them as they were created for this project. They're part of our larger outfall data set, but we marked them, we gave them numbers so we could refer back to them, but we did kind of set them aside. So we were, towards the end of this, able to iterate through the entire system and be able to say, you know, area by area, full upstream trace. But that was another kind of gotcha with this analysis is that in theory, it looked like places in the system didn't discharge to anywhere, you know, our outfalls to nowhere, but we were able to build that entire data set. So,
yeah, and those are questions that the city, those are some field validation places that need to happen to go out and see, you know, what is happening here? Where is the water going? Because there is a pipe, it goes somewhere. We don't know where. So,
yeah, and there were a couple other places too where, we could tell at one point some infrastructure was added to the network, and then maybe years and years later, more infrastructure was added for a different development. And that infrastructure kind of conflicted. We could say, okay, the water might be flowing out this outfall, but it also shows it's flowing out this outfall. So those ended up as more question points for MUCLTO, is what infrastructure is really in the ground and which way is it carrying water?
okay, anything else to add, Heather? Before we move on?
No,
okay.
Please go ahead.
Okay, so I'm just going to summarize some of the citywide results. We looked at the data overall in two different ways, kind of just in overall, just what's treated, what's partially treated, where there's no treatment. And so the map on the left gives you a snapshot of that. So the areas that aren't treated at all, that have nothing, are shown in orange, and the hot pink areas are considered fully treated. So, and then in between is the kind of purplish bluish color, which is partially treated. So there's a lot of opportunities, you would say, maybe say in the city for retrofit and treatment in the future. Looking at the types of treatment, so whether there's flow control and water quality, no treatment, or just water quality alone, the figure on the right breaks it down into the types of treatment that are there. So that just kind of shows you where there's flow control, which is blue, water quality alone is green, which kind of conflicts with the green parks a little bit. and then pink is no treatment, which corresponds with the orange. So yeah, that just gives a snapshot of, you know, when looking for retrofit, a good place to start. We also broke it down by basins as far as what level of treatment there was, fully treated, no treatment, partially treatment, by each individual drainage basin. So to give another way to look at this. And so like Goat Trail Creek has very little treatment. There's some areas that are just all partial treatment. So this gives us another way to look at it. And the city has some high priority watersheds. Big Gulch Creek is a high priority watershed. So are Lower Chenault Beach and Upper Chenault Beach Creek. So those two areas are also good targets for retrofit. So good areas to look at. And then we looked at it by ownership. And I know we didn't show any figures that by ownership, but you know, there's for the city of Mukilteo, I think you get the idea by the figures that were shown that there's a lot of opportunity for improvement and for retrofit, for treating untreated areas or even partially treated areas. But there's also opportunities for the private sector as well. And some of that may happen with redevelopment. Some of it maybe there's public-private partnerships that could happen as well. And then there's probably also a lot of opportunity for the facilities that are already there where it's fully treated to target better functionality of the systems that are in place. This map here just shows the NPDES permit requirement for the city-owned outfalls that are over 24 inches in diameter. So there's only 32 outfalls that the city owns that are over 24 inches in diameter. And some of these outfalls still need to be verified in the field. But it does show the treatment levels and the tributary areas to those outfalls that are of that size. So that gives another way of looking at the analysis that we did. And then lastly, I'll just briefly go over the next steps for this project. We need to field validate the outfalls and some of the drainage areas. So the city has a list that Heather created that, you know, some problem areas that were identified in the GIS analysis, including, you know, areas that we found, where is this drainage draining to, that is there an outfall or is there not an outfall? There's some areas that were questions as far as public-private property of, is this really happening? Is it public water going under private property? Is it public or is it private? You know, those types of questions that need to be answered. So there's a lot of little bits of field validation that need to occur. As far as the retrofit goes, as far as looking at areas for retrofit, there's a huge opportunity with what we did in this project to identify areas for retrofit. First, targeting the non-treated areas in the high priority watersheds, and then using that impervious surface overlay to identify the highest benefit. Also coordinating with the pipe rehabilitation program, which the city's been working on for the last couple of years. They've been doing a condition assessment of all their pipes, and they have a list of pipes that they need to replace or repair. And if there's opportunities to do retrofit in the same areas that they're doing pipe renewal, then that would be great. And especially if it's in the high priority watershed. And then secondly, to do the partially treated areas to either upgrade existing facilities or add water quality where there is none. And then the other part of this is they're implementing an inspection and maintenance program for private stormwater facilities with an educational component of training private owners to be able to inspect their facilities, and with the hope that they can do this and be better at maintaining their facilities. And if they do that and identify shortfalls in the functionality of their stormwater facilities, they can apply for grant money from the city to offset the cost of those repairs. So that is kicking off pretty soon. So that's all that we have, and I will stop sharing my screen so that people can ask questions to all three of us, or all three of our groups, I should say.
Thank you all. That was extremely formative, and there's a lot of information there with different paths and procedures to evaluate this information. There are a few questions in the chat. Do you have access to the chat, or do you want me to read those? And they don't specify one person. You might all be able to provide input.
Yeah, I can see it. And I do think Courtney responded to Dan's question. And Heather responded to Kevin's, and then it looked like Larry had a comment for Erin.
Yeah. And then anyone else, this is a great opportunity to talk to these consultants who have provided a lot of really good information. If you need any clarification, please raise your hand or write a question into the chat.
It looks like Courtney and Heather were able to have an exchange with Dan, and Kevin reached out and asking about the workflow. Chad Tinsley is our GIS lead for this work at Parametrix, and he did put together a pretty detailed methodology that we've been attaching to all the mapping memos to Department of Ecology. And so we could probably get you some shots of that. So if anybody needs that workflow, like if you have the layers and you're just like, how do I put this together? I'll work with Chad. Please email me at that address, and we'll get you our step-by-step.
Thank you, Julie. That's really generous to share that information.
And I'll just mention that Larry asked about the flow for some of the outfalls in Mukilteo, that for the fully treated areas or the no treatment or partially treated areas even, some of them might be flow control exempt because they're going to Puget Sound. And we did consider that, and it mostly involves the outfalls that are near the ferry terminal on the north side of the city. So those are the outfalls that are mostly affected by that flow control exemption. So if that answers the question, I forgot to mention that.
One thought I'll add, because it's come up from numerous different sources over the past week. I've talked to different people saying, oh, we should define tree. So just think about that in your codes for your jurisdictions. We have so many different requirements. Bill Leaf and I were talking about this. We're working with City of Spokane right now on their comp plan EIS. And I feel like, we're at this turning point potentially in regulation where we're thinking about trees more appropriately from many different points of view and for many different purposes. And we're trying to protect them. That's good. But there's a lot. Take a look at your codes and see whether or not you even have a definition of what a tree is, what you consider a tree for regulatory purposes, or if you have a definition of forest, so that I'm trying to caution the groups I'm working with they're like, oh, well, let's just put a definition in for this report. I'm like, maybe not. Maybe let's like work cross-jurisdictionally, get your legal department involved, get your maintenance crews involved, but just I'll throw that out as food for thought for everyone. Like, we have some really basic terms that we know it when we see it, but we may not legally be agreeing on the exact same thing.